perfect cubes are similar to perfect squares in that we have two terms and only two terms. However, we are not limited to there just being a minus sign in between. In this case, we're going to start with the sum of perfect cubes. Okay, so let's list out our perfect cubes like we did with our perfect squares. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed, I have to cheat on that one, 512, 9 cubed, 729, and 10 cubed is 1,000. Now, there's nothing special about stopping at 10 other than the fact that very rarely are we going to go any bigger than 10. You can, but usually that's about the limit on the perfect cubes that are going to be involved in our factoring problems. Okay, so let's write down our rule kind of like we did with perfect squares. So perfect squares, you had the exact same thing in both sets of parentheses, one with a plus, one with a minus. Perfect cubes are completely different, okay? So it starts out, you're going to have an A and you're going to have a B. Okay, that comes from what do I cube to get the first term? What do I cube to get the second term of my original problem? Okay, then from that, we are going to build our second set of parentheses. Okay, so what we do is we square the A, so whatever our first number is here, we square it. Then we're going to multiply these two numbers together, so we're going to have A times B. And then the last thing we're going to do is we're going to square the second term, so we're going to square the B. Now notice, I haven't put any pluses and minuses in here. There are pluses and minuses. I use the acronym SOAP. Same, opposite, always positive. Same, opposite, always positive. So what do I mean by same? Same is the same sign that was in the very original expression. So right now we're doing sum of cubes, so that sign is a plus. The opposite would be a minus, and the last sign is always positive. Same, opposite, always positive. So I wait until the very end before I put my signs in there. I figure out all my numbers first, and then I go in same, opposite, always positive. Here's the deal with the sum and difference of cubes. It's always a pattern, okay? It always follows the same pattern. There's really, honestly, not a whole lot of thinking that you have to do. Okay, so let's look at number 7. We've got x cubed plus 27. So we cube x to get x cubed. We cube 3 to get 27. So that's where those two numbers come from. X cubed is x cubed. 3 cubed is 27. Then we build our second set of parentheses. We square the first term. That was an x. So x squared is x squared. Then we multiply these two together. So x times 3 is 3x. And then we square the 3. So we get 9. Now we put the signs in there. The same sign, so the plus comes down, then the opposite, and then the last one is always positive. So same, opposite, always positive. And I will continue to repeat that until you hear it in your sleep. And the reason why I emphasize it so much is because if this is a multiple choice answer choice, a lot of the time you can eliminate half of the answer choices just based on their signs. So if all you remember about sum and difference of cubes is that I'm supposed to have SOAP, same, opposite, always positive, you can at least narrow it down to a 50-50 shot. Okay? So just keep that in the back of your mind. All right, let's look at number 10. Number 10. We're going to skip 8 and 9 for the moment. I'm going to let y'all do that here in a second. Let's look at number 10. 24 and 375 are not on our list of perfect cubes. So that means there's a GCF, right? They are both divisible by 3. Variable-wise, we also have a GCF, right? They both at least have a C, and they both at least have a D. So 3CD is our GCF. 24 divided by 3 is 8. We took 1 C out of 4 C's, so we have 3 C's left. And we took the D out. Plus 375 divided by 3 is 125. We took the C out, and we took 1 D from 4 D's, so we've got 3 D's left. Now we have the sum of perfect cubes. 8 and 125 are perfect cubes. C cubed and D cubed are perfect cubes. So bring that GCF down. 2 cubed is 8. C cubed is C cubed, so 2C goes first. 5 cubed is 125. D cubed is, of course, D cubed. So 5D is our second term. Now we build it. Square the first term. You got to square the 2 and the variable. 2 squared is 4. C squared is C squared. Multiply them together. 2 times 5 is 10. C times D. They're not the same letter, so we just got to leave it as C times D. And then square the last one. 5 squared is 25. Square the D. And then so, same, opposite, always positive. Okay, it's just a pattern, over and over and over and over. Okay, let's do the difference of cubes. Nothing changes except the signs. So if you really want to write down the rule, the only thing that changes is it's A minus B. We still square the A, we still multiply them together, we still square the B, but this time SOAP tells us it's a minus, opposite is a plus, and the last is still always positive. Okay, so nothing has changed. Process still the same. Our signs are just a little different because we started with a minus. Okay, let's do number 11. Let's do number 11. X cubed minus 1. Perfect cubes. We cube x to get x cubed. 1 cubed is 1. 1 is a perfect everything. Square the x. Multiply them together. X times 1 is x. Square the 1. So, same, opposite, always positive. Minus, plus, plus. Now, I haven't mentioned this yet. Somebody is probably thinking that this trinomial, the 3 terms, does not ever factor further. This will never factor further. It's really, really close, but that middle term needs to have a different coefficient to be able to factor that expression further. Okay, so that is as factored as these things get. Okay, let's look at number 13. Okay, 4, 32. Not perfect cubes. So that means there's a GCF. They're both divisible by 4. Don't forget, you have to put that 1 there. Okay, you have to put that 1 when you factor out the 4 from 4. 4 divided by 4 is 1. Now, I know somebody's probably wanting to change that order, put the variable first. Technically, you can. Just leave it. Okay, just leave it, because if you move it, then you got to be careful with your pluses and your minuses, and it's not worth it. Just leave it the way that it is. All right, 1 cubed is 1, 2 cubed is h. Square the 1, multiply 1 times 2h, square the 2, square the h, 4h squared. So, same, opposite, always positive.